Welcome back to my channel. Today I want to try to machine this small battery tray to house this battery in the side of this robot project I'm working on. It's a part that can be machined on a 3-axis machine, but since I now have the 5th-axis trunnion, let's try to make it on there, because this part at least has 4 sides to machine. This side, that side, from the top, and there are holes on this side. So this is the end part. I modeled the stock around it, where we're gonna machine the part out, and I have my trunnion dovetail clamp. So here you can see where we're gonna hold the part. I want to try to record and explain the steps I'm gonna take to make this part. I'm not sure if I'm gonna take the right steps, because it's the second time I'm gonna machine a part with the trunnion, so I'm not sure if it's gonna be the right workflow, but let's see, and maybe we can learn some things today. So the first thing I need to do is machine this dovetail on the stock material. Just do that in the normal vise, and then after that we can grab this piece of material in the trunnion. So let's make the program to cut the dovetail, cut it, put it in the trunnion, and then I will explain how I set the Z height again, like I explained in last video. I created the program for op0 to machine the dovetail. So first thing is rough out the top material with the face mill, then finish it so only this square remains, and then use the dovetail cutter with some multiple passes to cut the actual dovetail, and that should be enough to hold the part in the dovetail vise. So let's put the material in the vise, set the 0 point, and run the program. I loaded the stock material, set the 0 point, and did the spindle warm up. So now let's run the program. Now let's run the dovetail cutter and cut those dovetails on the side. Loaded the dovetail cutter, let's run the next program. So now we can transfer the part to the dovetail, and then set the 0 work point for this stock material. I mounted the part in the dovetail clamp, and I made sure that this side is parallel to the y-axis now, and I set the c-axis to 0 degrees in this position. The b-axis is now also at 0 degrees, and it can tilt down to -90 or +10. Because my controller doesn't have the true center point control, my work coordinate system is in the middle of each rotation axis. So I need to set the work coordinate set the work coordinate system somewhere here in the middle of this axis and this axis. The only thing that is unknown for me is where the part is in space in relative to the work coordinate system. So what I do is I put my machine in G55, the work coordinate system I use for this trunnion, and then I use the Heimer to measure the top of my stock part. I know that the 0 point is here, and now I know I put the Heimer here on 0, and then I can take the height difference to model up the top of the stock in Fusion. So let's go back to the computer and make a sketch, so we know, so we can set the work coordinate system offset from this point to below there. So what I did is I made a sketch on the center plane straight through the middle of the part, and I draw a line which has exactly the length that came out of the z-axis measurement, and then I created a point on the end of the line, and this point will be the work coordinate system center point. So from now on, Fusion will know where the stock is in relative to the 0 point. This is now how the setup looks like. You can see the coordinate system is at the bottom of the point of the sketch, and the y-axis is in line with the long side of the part, just like how it was now fixtured in the machine. For the model, I used the model of the battery tray. I set the fixture, I set this part, and for the stock I used the modeled up stock, and I did a work coordinate system offset, so it will output the program in G55. I already made this mistake, don't do it, and then the machine stays at G45 and you get some interesting things. Luckily I was in time to catch the problem. So now we all have this set, we can start making programs on machining this part. I created the first 2 programs. They will rough out the outside to the shape of the outside contour. First with a short 10mm tool, and then with a longer to reach the bottom. For this operation the trunnion doesn't have to move, I can just stay straight up, just like it's a 3-axis move. I first want to finish the outside contour like this, while the part is still rigid as possible. If there will be some chatter on the inside, I think it's less a problem because you will not see it, but I want to try to make the outside as clean as possible. So let's run this program and see how that goes. The program is loaded for the first step. I'm gonna hold my hand on the feed control so I can see what happened in the first stage of the program. So let's run it. The outsides have now been roughed out. Now let's make a program to finish the outside contour, and then let's work on the inside. Now that the outside has been finished, the next step I want to take is 3D rough the first 15 millimeters from the top part, so the top layer will get exposed, and I can finish that while the top part is still rigid. So that's what I'm gonna do now. First rough it, and then we gonna finish this whole outside part to make it look good. The first 15 millimeter has not been roughed out. What I want to try to do is use a 6 millimeter end mill and machine from this side to finish this half, flip it, and then machine this half, and then I can also see how nice, or if it's aligned at all, to see if there's if you can see a mark in the middle. If the end mill goes from this side and this side, will be the difference in the middle. So let's make the program, and then we can also use the 3+2 function and tilt the trunnion. So let's make the program for the machining on the side. So what we're gonna do is select contour, tilt the trunnion like how I want to have it, and first thing we need to do is select the right tool, and then tool orientation, and we need to give the trunnion a new z-axis. So you can see the z-axis now pointing upwards. For x and y you don't have to touch it, Fusion will figure out itself. Then we can select the contour, and all I want to machine is this side, so I'm gonna mark what I want, okay, and from the top it will look like this, and then I need to set the right height, and I want to go here -10, which will be exactly in the middle. So let's do 0.5 millimeter deeper, so we have some overlap between the two passes on each side. And I will set top here, and that should give us our program. So I'm first gonna do it with a stock to leaf of 0.1 millimeter, and then I can first verify in the machine how the program looks like, and then we still have the 0.1 millimeter escape if it doesn't turn out how I want to have it. So let's post it and put it in the machine. I loaded the program and loaded the tool already. Let's run the program. I'm gonna hold the feed button again to see if the trunnion does what I want it to do, and see how it's gonna turn out. Okay, that looks like what I wanted. Now the question is, if we rotate Z-axis, put B down, and we do exactly the same thing on the other side, how this intersection will look like. So let's make that. I will make that program, and then we're gonna put it in the machine and see. I loaded the program for the other side now. I'm gonna put the feet low, so first I want to see how the trunnion gonna move, and let's see. Yeah, looks good. Let's see. You can feel something, but I think it has more to do with the lead in, lead out than an actual height difference. So let's see if I can optimize the program a little. I modified the lead in and lead out a little, so it goes in straight instead of the loop. I adjusted for both programs, and I get the stock to leave to 0.05 of a millimeter. So let's run this program again, two programs at the same time. So in the middle of the program the trunnion will move, and see how the transition between the two passes will look like. Spinner will get out, rotate the part, spinner will come back. Let's look. Nice. There is still a little bit height difference, but almost invisible to see. So I think for the way that's a home built trunnion, the aligning is for now good enough. Now next up is to rough all the inside. I first gonna drill a hole, and then I located my helix entry of the adaptive cleaning there, because I cannot use flood coolant yet. I always have trouble that the end mill gets full with aluminium on the helix approach, so with this pre-drill there's less material for it to remove, so hopefully it doesn't clog up. The inside of the battery tray is now roughed out. Time to make the finishing program, and then we can work on milling all these holes around. Now that the inside is finished, it's time to machine all these weight-saving holes in the sides. I want to start from the top, work my way to the bottom to keep the part as rigid as possible. So first I want to do these two, then the 4 top one on this side, then this one, rotate the part and do the other 4 top ones, rough them out, finish it, and then start on the lower ones and do the same thing. And I think I'm gonna do it in 3 parts. So let's make the program for the first 2 slots. I'm gonna use the contour function. I'm gonna select my 3mm end mill, and first we need to do is the tool orientation again. So just rotate the part or the trunnion how you want to have it on the machine, and then select the new Z-axis. Again, you don't have to bother about X and Y, Fusion will figure it out themselves. Then we can select the right contours, so these two, stock to leave, let's go 1mm lower, so we're 100% sure we break through, and we're gonna use the zigzag to get inside, because there is no space for the tool to have a nice lead in. And let's set the top at this height, because the material is already gone. So that's this side. Program is loaded. Let's machine the first slots and pockets on the side. Pockets on the first side, on the first layer, are finished. I'm already made the program for the pocket on this side and the first pockets on this side. So let's run that program. I think the part is still rigid enough to do the last pockets just all together. So I made the program, and I'm gonna post it as one big program to machine all the remaining pockets at once. So let's post it. Next up is drilling those 2 holes for the cover plate that needs to keep the battery inside, and drill those 3 holes in the bottom of where I will mount this bracket to the frame plate of the robot. And then I want to do a 3D contour to machine this countersink, which I cannot reach with a normal countersink drill. So I need to mill it in. finished the machining of the countersinks. It was a little bit sketchy because the tool is pretty thin and high stick out, but I think it turned out good enough. Last thing I need to do before it can remove from the dovetail clamp is chamfer it. Unfortunately, I don't have a back chamfer tool, so I can only chamfer the front sides, but the inside it's not sharp at all. Up 1 is now finished. All pockets have been chamfered, which I can reach. Battery fits in perfectly. There will be a cover plate with 2 forks getting inside these slots, and then 2 bolts to hold it on this side, so the battery cannot get out. So what I now need to do is get it out, put it back in the vise, and face off the back side, and then we should have a finished part. For facing off the back side, I put the piece back in the vise. I use the parallel here to so I can clamp it, because there are the notches for the bolt. Z0 is the top of this parallel where the mounting lip is resting on, and for X and Y I put the middle of the stock. So now I'm first gonna adaptive clean this flange off, which is sticking out, and then I can face mill it to the correct height. And here we have the finished battery tray part. It didn't turn out too bad. There are some things that I should have done differently. I forgot that these notches will extend till here, so I manually jogged an end mill around it, but it shattered like hell. So this finish is not nice anymore. I should already clear this side when the inside wasn't milled out. Things to keep in mind for next time and other thin objects. Battery fits inside nicely, so now I can make the cover plate. But this will be the end for this video, to show you guys a little about how to make the part, how to make a part with the use of the trunnion. Well, thanks again for watching, and hope to see you guys back on the next project I'm gonna do.